Let's prove this property of logarithm we call the power property. This tells us that if we have here a logarithm of an exponentiation with the base b, this is just equal to taking out that exponent as a coefficient of the logarithm of x the base to the base b. Now this is different from the inverse property of logarithm, because in the inverse property of logarithm, our exponentiation here has the same base of b. This time, our exponentiation here has base x, so they are different. Hence, we'll be using this. However, we are also going to use that inverse property of logarithm as we show this proof. So we start here with this, okay? Similar to the previous two videos in proving the product property and quotient property, you might want to review on that. We are going to assume here, first, this equivalent logarithm. Okay, let logarithm of x to the base b equal to a certain expression, let's say m. I know and understand that if we are going to show a certain proof or theorem, we start with this and it should end up here. But let's just try this representation first so that we could use this as we look for the value of x to be used here, so that later on we can show the process with ease. Now, before with this, take note that we have the transformation, the logarithm of a certain expression a to the base b, which is equal to, let's say, let's use y, okay, so that we will not be confused with whatever be the variables here. This can be transformed into another exponentiation. We have here, we have b, you have this base b, this would be its exponent y, okay, this is equal to this expression here, a, okay, and that's how it should be. Now, from here, again, this is true from logarithmic equation into exponential equation and vice versa. We're going to use this property because what we would like here for this representation, we would like to come up with the value or expression equivalent to x. So with this, following the transformation, you have b raised to m, okay, is equal to x. And from here, we now have a representation for x, and we can now start from here to that. So we have the logarithm of your x to the power of k to the base b, substituting the representation of x. Okay, sorry, my screen was not able to capture the rest. So we're going to have the logarithm of x to the power of k to the base b. As we use b to the power of m for x, we have here the logarithm of, you will have this form, b to the power of m raised to k, right? Because that is actually x to the base b. Again, this is what happens. This was x as emphasized here. So this, again, laws of exponents, we have power of a power, and if we have that, the logarithm will have to multiply the exponents b to the power of mk or km, arranging them alphabetically, but let's just have this in the meantime to the base b. Okay, so from here we only have one more step to show what is the simplified form of this, and this is where we are going to use here the inverse property of logarithm. The inverse property of logarithm tells us that if we have the logarithm of a certain exponentiation where the base of the exponentiation is the same base of the logarithm, this is equal to the exponent of the exponentiation itself. This was already shown in the previous video pertaining to the inverse property of logarithm, so please try to review on that if you would like to know how it was proven. So again, this is different from this. Compared to, in the inverse property of logarithm, the base of the exponentiation is the same base of the logarithm. But this power property, the item we are trying to prove as of the moment, we don't have the same value. Hence, we will have this proof. Okay? So with this, take note that again, if we have the same bases here, we just copy the exponent and that's the result. Similar here, we have the same base. In short, the entire value of this is equal to the exponent itself, mk. Okay? M and then k. So what I would like you to do here next is this. We're going to remove these two portions as we take only these two portion of the equivalence here. So we have the logarithm of the exponentiation x to the power of k to the base b is equal to m times k. Again, that's m times k. But what was m? Going back here, m is actually the logarithm of x to the base b. And by substitution here, we'll have the logarithm of the exponentiation x to the power of k to the base b is equal to your m, which is the logarithm, this one here, the logarithm of x to the base b times k. And simply just arranging them to match with the property, we have here the logarithm of the exponentiation x to the power of k to the base b is equal to k, the exponent, times the logarithm of x to the base b. So this is the proof for this power property, which again tells us that if we can express our identity here or item here or expression as an exponentiation with not having the same base as this, simply take out the exponent, make it a multiplier to the logarithm of just the base to the same base of the logarithm b. This is already proven here. Okay? So this is property. So this is properties, laws, and theorems. Please subscribe now.